Hey everyone, welcome back to another exciting video on system design concepts. Today we are diving into two fundamental building blocks of scalable systems, message queues and message brokers. These tools are the unsung heroes behind asynchronous communication in modern application. Let's break it all down. First, let's start with message queues. What is a message queue? Um, a message queue is a data structure that stores messages in a first in, first out order. Think of it like a line at a coffee shop. New order go to the back, and the barista process them from the front. This setup unlocks asynchronous communication between producers and consumers. Why is this game changing? It allows applications to handle requests without waiting for each task to complete. Let's take an example of how it works. Let's assume that we have a system and we have a user, and this user will want to upload file, so it will send the file to our web servers. And yeah, a user will upload the file, the web server will receive the file. It needs to create a job and stores the file in an object storage. So how this will happen? It will create a job to the message queue. Let's give it a different color to make it more appealing. And the job will be sent to a worker, and the worker will store this file into in a blob storage. And also we need to no. And also we need to add like an arrow because the observer needs to read. Oh no, go back. Okay, that's good. So a user will upload a file. The web server receives the file, creates a job, and stores the file in an object storage. It will handle this through a message queue, through the message queue, and a worker will process later pickups the job, retrieve the file, and process it. The scheduling and management background tasks, the message queue basically do four things. First is scheduling and managing background tasks, distributing tasks across multiple workers, um, using the computing consumer pattern, handling retries for failed payments or failed operations, and sending email and notifications if anything happened unexpectedly. Okay, so this is an easy, simple example of message queue. We need to talk next about what is a message broker. What are the differences between both of them? A message broker is a middleware that manages one or more message queues. It also supports other features such as message routing, like this is about directing messages to different destinations based on certain criteria. Brokers use routing keys to send the messages to the correct queue. This is like the flight number of a flight ticket. We have also message transformation, like changing the message format or content, and also there is a protocol translation, converting one protocol to another, like HTTP to GMS, for example. Okay, let's take an example of how this will work. So let's say that we have like an order service, and we have um, let's say a notification service. No, notification, and yeah, and both of them will send requests to the message broker. Okay, I guess this doesn't look good. Let's make it like that. Yeah, this looks way more better, to be honest. Like this way of handling the errors. And the message broker has multiple queues, so it might have two message queues, one for order service and another one for notification service. And for example, we might have like an inventory service, like an and shipping service. And the inventory service, it will be like for yeah, working for with the order, for example, inventory service. And we might have also like yeah, a shipping service. So if you try to look at this example, we have the order service, and let's just make everything here. The order servers will publishes and create order message when an order is placed. The inventory service will subscribe to the update stock levels, and the shipping service will subscribe to initiate the shipping process. The notification service sends the confirmations, emails, or SMS. Okay, let's try to understand this again. We have here the order service. When a new order is placed, it publishes create order. And when we have a create order service, it will send it to the message broker. We might have like two message queues in the message broker, one for the order service and another one for notification service. And maybe the notification service will be subscribed to the the inventory service will subscribe to the order service of the message queue of the order service. And whenever we have a new order, the message queue will subscribe to the create order message to update stock levels. And the shipping service also will subscribe to the create order message to initiate a shipping process. And the notification service will subscribe to various events to send emails or push notifications to to consumers. So um why is this why message queues and brokers, why this is happening at the core? Message queues and brokers solve three major challenges. First, asynchronous communication, like no more long waits for users. Number two, fault tolerance, like retry mechanisms ensure reliability. Number three, scalability, because they easily handle millions of messages across distributed systems. So whether you are building a notification service, integrating microservices, or processing tasks asynchronously, message queues and brokers are essential tools for modern system design. If you found this video helpful, make sure to subscribe and hit the notification bell so you never miss any video, and see you guys in future problems.